Kárpótoljuk Önöket most a következő előadással a rövidebb szünettért. Nevezetesen, hiszen már rögtön a bevezetőben azt mondtam, hogy a konferencia főelőadó John Sukor, és ez ki fog derülni, hiszen több előadása is lesz a nap folyamán. Most az ebédszünet előtt a Tanulj meg látni című könyv alapján megmutatja nekünk, hogy egyáltalán a Lean szemlélet hogyan alakult ki, hogyan voltak a kezdeti folyamatok, és aztán tehát miből lett a mi. Erről fogunk most hallani, aztán később majd az én veszőparipám, az A3-as is szóba kerül egy másik előadásban. De én akkor meg is kérném John Sukurat, hogy fáradjon ide a színpadra, és mutassa be egyrészt ezt a könyvet, másrészt a kezdeti folyamatokat.
I have a deep interest in both of those topics. One is the research and education. And I was delighted to hear that you actually take the learnings from research and make sure it's plugged into education, as someone asked about, because that often does not happen, which is a real problem in the world. And one of my initiatives in the U.S. is to work on education. So just last week we had a meeting, gathered together 15 professors from different universities to talk about research and education. Because some of the training we have to do in companies is arguably rework. Right? If we did a better job, perhaps, of teaching some of this early, we wouldn't have to do the rework. So it's lucky that, for educators that there's no warranty. And so you can't ask for a recall. Or some of our students might come back and say, you know, and demand a better education. Even MIT, which is where the first lean production research occurred, it's not taught very much in the school. So it's a shame. It's a problem, and that's a problem that I want to take on. The other topic about books. Well, this is a book. So now I am a publisher. So I have a deep interest in publishing and learning about it. It's this crazy business, and it is one that is headed for a revolution without question. That there will be a revolution is without question. Exactly how it will happen, we don't know. Where it will land, we don't know. But I think I'm going to try to add a couple of slides at the end of my presentation. I asked Szabolcs if he could add a couple of photos that may give an idea of where this industry is heading, because it is interesting. So there's this book we call Learning to See. So both of these books have interesting titles in English. I don't know what the Hungarian title nuance is. But ordinarily, you wouldn't call a book Learning to See. In fact, just to talk about it a little bit more, when this project, to do both of these books, I was a very reluctant author, reluctant participant. I thought it was a bad idea in both cases to do a book on this topic. In this case, I thought it was, in both cases, I thought it was a bad idea. I hope I was wrong. But what convinced me about this one actually was the title. I was very concerned that, we're just going to unleash another tool on the world. There are already enough tools in the world. And it's not lack of tools that causes the problems that companies have, I thought. So why introduce yet another one? And then one day the publisher said, okay, the title will be, because publishers decide titles, right, traditionally. So the publisher said, the title will be Learning to See. And I said, okay, I thought this was a bad idea before. Now I know it's a very bad idea. Learning to see? No, I want nothing to do with this. But then I thought about it, and I realized it was exactly the right title. To me, it was going to be the subtitle. I don't know how the subtitle came out in Hungarian. The subtitle is Value Stream Mapping to Add Value and Eliminate Muda. So I said this will be a material and information flow handbook. That's the title, because that's my image of what the book would be. And that might be accurate, but it may not have sold as many books. So this one is in about 15 languages, actually sold about 400,000 copies. And it turned out to be quite a phenomenon, and I think maybe it helped. So to give a little bit more of a background about the entire topic, not just the book. And it relates very much to this topic about books and publications and what may happen in that world. I mentioned before that we have this, that this lean came from the MIT International Motor Vehicle Program, this research. And Toyota production system was identified as lean production for the first time then. The authors at that time of that book and that research didn't really know everything about what lean was. They had identified certain parts of it. And they didn't know all about the complete history. It actually includes a lot of things, not only from Toyota. Much of it started at Ford. Henry Ford, about 100 years ago, created flow production. And that's part of what lean is all about. That's what we were hearing about, in fact, earlier in the discussion of books. I'm going to explore that a little bit more, if you don't mind. And then there's PDSA or PDCA from Deming. How many of you know what that is? How many of you don't know what that is? Okay, yes, that was a binary question. I was testing to see how many people are listening. That was yes or no. About 10% of hands didn't go up on either question, either one. So I don't know what that means. But I know it means something. And anyway, mainly means just doing science. This was developed in the Bell Labs in the United States. So it was born in a laboratory, how to do experiments and make them real. And then translated into a construct for how to do work by Edward Deming. And then there's Toyota's JIT, System Dynamics and Supply Chain. And that's, again, that was part of the previous presentation. But also the way Toyota and some other companies, perhaps, the way they engage people to build in quality. So quality is built in right here, right now. And to solve problems so that we're continuously making improvements. We're continuously improving every day, every day. And there's this management system. So when the original, lean production was coined, they weren't really thinking so much about the management system. So that may relate to some of the questions about why the sustainability has been a little weak, because our early understandings were probably a little too narrow. That could relate probably to the answer to that question. So it's a highly developed social and technical system, and with a focus on how to develop system and people. So here's the definition that I am playing with now for lean thinking, lean practice, and we're talking now about value streams, how to make value flow. So I don't know, so what you try to do with these things is be as concise as possible, right? So it's Einstein said, be as simple as possible, but no simpler than necessary. So maybe this is too simple. Maybe I'm leaving something out, so you can tell me. We can talk about it. But notice it starts not with the last part there. It doesn't start with eliminating waste or making value flow. I'm saying that what we're trying to do is develop people and the processes we work in, and the systems. So there's a process for making a book, right? So it goes into the big machine, the printer that we saw. There's an overall system that has to do with how we buy books, how we sell books, right? How they're used out in the world. That's the overall system. So we want to develop people, process, and systems to meet customer need. So what does customer need? Customer wants, in books, they want the content, right? I guess. And they want it when they want it, right? I guess. And nothing extra, I guess. So to meet customer need while consuming the fewest possible resources. So whereas traditionally in lean thinking, we talk a lot about waste, okay? And I'm kind of using these words instead, because sometimes in lean thinking, when we talk about waste, we talk about the kind of waste you see on a factory floor, whereas actually it should be broader than that. Anything more than necessary, any kind of waste. So that's my current definition that I'm using today anyway. Next week it might be a little different. So I thought I would, to share this story, Szabolcs in the Lean Institute Hungary asked me to talk about kind of the history of this, where it came from. I don't know how many people want a history lesson exactly, but I thought I would share a little bit in talking about automobiles. Why talk about automobiles? This particular system was born out of the auto industry. That's one reason. Second reason is something I happen to know. That's where I worked. The third is the automobile industry is very interesting because it is so massive and so huge. It entails every other industry. Right? I was in Silicon Valley in California a few weeks ago, and there was a CEO of a semiconductor company that was telling me how simple the car business is compared to his semiconductor business. And I said, do you realize how many semiconductors are in a car? So the car has that complexity, plus all the other things, plus mechanical parts, all the electromechanical parts, everything. There are more lines of code, speaking of computer, software code in a car than in a Boeing 747 by many, many times over. So it's incredibly complex, has a very, very long value stream, supply chain. And because of that, the people who run that industry had to really think about the system, how to construct the system in a way that they didn't go crazy. They go crazy anyway. But they have to. If it's a simple business, you may not think about it so much, but you have to in the auto industry. So here's a kind of a century of value stream challenges, I decided to call it. And I just made this up. These are what I have, 5 or 6 things. So the first thing that happened about 100 years ago, as you know, over 100 years ago, there were just hundreds, even thousands of car companies in the world, very small ones, trying to learn how to make cars and to do it cheaply. What they were trying to do was provide reliable, affordable, personal mobility. So if you think that's the basic need that a car answers, right? A book, it's providing the content that I want to have in my head, I guess, or maybe some pleasure. But the car, the first thing was transportation, right? And it was Henry Ford who did that with his Model T in Highland Park, Michigan. It's a wonderful place to visit. It's this old broken down factory, not used for decades. I like to go through there and just look around. I do that. I sneak in, quite literally. And then, after Henry Ford did this, GM, General Motors, came along and added some complexity to it. So Henry Ford's world was kind of nice, easy. And then GM comes along and says, we want a car for every wallet. So someone who wants a cheap car. So I saw, for the first time, I've had a chance this trip to see a Trabant. Trabant? It's beautiful, 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 beautiful. Love it. I love it. So people who want, or now, I guess Tata is supposed to be makes the cheapest car in the world today, I suppose. And then we have very expensive cars. So General Motors did this about a few years after Henry Ford made his Model T and the assembly line, the famous assembly line. So what happened then is a problem developed. I'm going to talk about that. So he brought in fashion, basically. And even today, okay, we have, in the mid-level of cars in the world, we have Passat, and the Camry, and the Accord, and the Ford has the Fusion, and some others. There's no difference between those anymore. There's no difference. It's a matter of fashion. Oh, I like Fords. No, I like Toyotas. There's very little difference between those cars anymore. But there is a fashion statement. That's okay. That's what we want. So transportation, fashion, and affordability. So what Toyota did is they merged these so that it could be done so it could be effectively and efficiently. And I'll show what that means in a moment. And then we have the globalization that occurred in the last few decades, and we even heard evidence of that regarding the research, where you found that it was these general managers from the multinationals who come in and bring the different technology. So we've been seeing the diffusion of the Toyota production system, or lean production and lean management, for the last 20, 30 years. And of course now the big challenge is environmental sustainability, yes? And that's the next frontier. And so the auto industry, once again, is in total upheaval as they try to figure out how to meet this challenge. And I say here that Toyota has a slight lead. That lead may already be almost gone. They had a lead probably for a couple of years. And right now, who knows? But certainly, it's going to look very different 5 and 10 years from now. There's a huge revolution happening again, right? So that's interesting. So here's some thoughts for you with the thinking of the car industry, but also publishing or anything you want. I'm going to suggest the problem of production. So when we think about producing things, we always focus on the sexy part, which is, how you actually, mold this, and the machine that's done, that's necessary to put this together. Maybe have a robot to put it together and all that. But what's most difficult often isn't making the product per se. It's organizing all the parts and materials that go into it. And from a management standpoint, that's what kills us. That's what keeps us up late at night. And that's what gives us the problem to solve, and therefore we develop management systems. That's the way I think of it. So in the case of cars, so if you work in the car industry, you know this is not true. But people outside the car industry think it must be easy because all cars are basically alike. It's high volume. You're making these things. It's amazingly untrue. 20 to 30,000 parts, depending on how you count, come together at exactly the right time once per minute. A car is not a car until it has all 30,000 parts. And they're coming together at the right point in time every minute. It's an amazing thing, actually. And every single part in a car, people don't realize, is engineered for that car, for that model. Every single thing. You know, even like commodity parts, supposedly commodities, like tires and glass, engineered for that product. So again, amazing complexity in the automobile. Most cars are unique. In the factories that I used to work in, in the course of a month, about half of the product that we would make would be a completely unique one. We'd only see that exact model one time the entire month. Half of them. So that is a red four-door with the automatic transmission, with the high-grade radio, and all those options together. Most of them unique. It's an amazing thing. Again, it's a lot that goes into it. So back to Henry Ford. This is the photograph of that factory I was talking about a moment ago. This is in Highland Park, which is a little island inside Detroit, Michigan. And in 1913, he put together this system. He figured out how to make flow production work. People had been working on that for many, many years in different industries, possibly with some success, but he had to put a lot of things together to make it work. So to get everything flow through his entire factory. I showed this book here because it's interesting. He was completely open to share everything that he knew. He had journalists, these were some technical journalists that wrote this book, that as he was putting the system in place, they were there documenting it, and published this book in 1915. You know, so many companies are so careful and try to keep secrets. He made it completely open. He didn't care. He was sharing with the world. So he had this end-to-end flow was what he was trying to get. This is a photograph. How many of you have seen this before? I don't know. But this is probably the first assembly line. That's what they say. So this is where they're making a magneto in Highland Park, 1913. So before, you would have had one of these individuals in one part of the factory with one machine making a whole lot of these, just like the big printing press we saw, making a lot of those. Then someone would come along, pick up that big batch, take it to another part of the factory, set all those down, where someone different would be sitting at a different machine, and he would process a lot of those. And after he did that, put those in a big batch, then they'd take it over to another spot where they would do more. In this case, they put all the steps together so you can do one step, this is one piece flow, one operation to the next. So the improvements in productivity that he achieved were phenomenal, about 900% just doing this. Amazing, amazing thing that happened. And we all learned this. So this has become kind of our accepted standard for how, you know, production can work. And he wanted things to be one giant conveyor. So after that factory in Highland Park, he built another one. It was the most famous factory in the world, called the River Rouge plant. The Ford Rouge plant. Giant, just massive thing. If you fly over it, if you ever fly over Detroit, you can see this big gray area. It's like a black hole there. It just sucks any kind of light. So it's still there after all these years. And his vision was giant conveyors for ore to assembly. So he bought rubber plantations in Brazil. Okay, so everything he would bring in, he had, if you can see it here, he would bring in ships that would have the raw materials, and he would take the raw materials and spit out a car at the end of it. This bunch of giant conveyors. An amazing thing, amazing thing. This is it again, and we had 1.4 million square feet, 100,000 workers in one factory, 160 kilometers of railroad track inside the factory, 24 kilometers of roads inside the factory, 190 kilometers of conveyors, 6,000 suppliers. An amazing, amazing place. But there's a problem, which is now Ford is trying to combat General Motors and make different kinds of products, bigger engines, smaller engines. And he had figured out how to flow with no product variety. It's actually easy, relatively easy to flow with no product variety. But as soon as you enter any variation, now it becomes very difficult, right? So that was the problem that the auto industry found itself after GM imposed product variation on the Ford production system. And that's what we were all living with for decades, okay? So this is what it looks like as a kind of a little cartoon. So as Ford said at that time, many of you have heard this probably, you can have any color car you want as long as it's black. That was there was zero variation, okay, for color or anything. And he can make it flow, but it's kind of not so hard to make it flow, right, when there's no variation. So the way cars are made, and Ford taught us, car factories are still pretty much what Ford showed from 1913. You have stamping, you have to stamp it, right, just like this was molded. Then it goes over, and you have a bunch of stamped parts, and you have body welding, or body assembly, put the body together, screw it together, weld it, and then you have to paint it. Then after paint, there's usually some inventory, some stuff. And then in assembly, you know, you stuff it. So you stamp it, you weld it, you paint it, and you stuff it with stuff. And finally, at the end, everyone was happy in the beginning. They got their mobility, so you know, any color you want as long as it's black, okay? So that worked okay, building up a supply base. Here's what happened next, which is when you have this production system, but customers who want variety, you have a problem. So here you see now a customer here at the end. This guy's wanting an A, but the A's not available. He's going to have to wait until there's an A, unless, of course, the factory makes up a whole big lot of inventory so someone can go get what they want. So that's what happened, right? So in the auto industry, you have an average of 60 days of inventory at the end of all this. Even today, that's the way it was for many, many years. Someone's coming along, you don't know what that person wants either. And this person maybe was happy getting his B. So what had been before, I'm going to back up, smaller amounts of inventory, now that all just explodes. It exploded much more than this. Right? So if you look in a traditional factory, and many of us who've been through lean transformation, you've seen this, right? Traditionally, there's all this inventory everywhere. It's a mess. You can't find anything, making the wrong parts. Whenever you have too much of something, you have everything but what you need. And that's what we've been living in for years because we had a production system Ford designed for no variety, but then we forced variety into that system. And we were living with that for a long time. And Toyota then solved that dilemma in about 1950. And they did it because they had a problem to solve. It's not that they were geniuses, not that they really sat back and designed this thing with perfect theory. They had a problem to solve, which is they decided to catch up with the major global automakers in 3 years. But to do that in 3 years, they had a challenge because they had a small market. They had productivity of about 1/10 that of Ford or GM or Volkswagen, 1/10. But they had a small market, and in that small market, they had to make, even with the small volume, they had to make everything. Big cars, little cars, little passenger cars, trucks, fire engines. They had to make all this. So Toyota, when they started working on this, they were making about 1,000 cars per month of all the different varieties. Now, Ford or GM or Volkswagen, they made 1,000 cars per day on one assembly line. So the difference in scale was just absolutely just off the charts. But they wanted to catch up. They also had no money, by the way, zero money in Japan at that time. So they're borrowing money from the banks. The banks were getting tired of loaning them money, actually, and refused. They stopped finally. So then they couldn't meet payroll. They couldn't pay the workers. The workers got very upset and went out on strike. So in the middle of that, they said, okay, somehow we need to catch up with the big three, or the global automakers. So to solve that problem, they came up with this production system that maybe we'll talk a little bit more about as we go forward, where you have the customer requirements. You somehow have to cook that in a way that makes sense to your system, level that. Okay, we'll talk a little bit about that. So you can make a C and then a B and then an A and then a B and a B to match what the customer buying rate is. If the customers are buying and wanting it at roughly this kind of a rate, this many C's versus this many A's versus this many B's, I want to mix that all together. So this was a great innovation back in 1950 that was part of just-in-time that we've all learned about for the years. And at the same time, instead of having a push system, as we heard earlier regarding books, now I've changed the way this whole thing works. First of all, I have my stamping inside the same factory. And it kind of seems obvious, but until recently, and even today, a lot of car companies don't do this. It creates tremendous complexity. In the same factory, so what I'm going to do is I'm basically going to try to flow where I can, just like before, and pull where I can't. And that's going to be a defining principle for how I'm going to organize the entire production system. And that's actually what we try to introduce in the book Learning to See. in a way that anyone could use those principles and techniques in any kind of production environment. That's the intent anyway. So that's at a high level what it looks like. So for this to work, there are a couple of basic elements, most basic things, okay, which I will introduce briefly. First of all, you have to have built-in quality right here, right now, at each step. So a lot of the famous, better quality of some of the Japanese companies, Toyota and Honda, that, from the 1970s and 1980s, it came from this, from realizing, well, we don't want to do rework. We don't have anything extra, so we're going to make sure that each step along the way builds in perfect quality. Again, it sounds obvious to us now, of course, but this was actually, again, an innovation at the time. Because what Henry Ford had said to everybody, believe it or not, in 1913, he's told the workers, the plant floor, he said, you don't have to worry about quality. Management will take care of that because we have higher paid inspectors at the end, and we'll fix whatever's wrong. He said, you just produce. Okay, Mr. Worker over there, Mr. Worker here, you guys produce. Management will worry about quality. Toyota turned that on its head completely. Said, okay, Mr. Worker, you don't worry about volume. We'll take care of that by how much capacity we put in place. You worry about quality. Everything you do, don't neither accept a defect nor pass on a defect. So that became principle number one. Okay? And so that's why when we begin our lean transformation, we start with quality. So that's why also, by the way lean thinking has turned out to be so powerful in healthcare. Well, it turns out quality in healthcare is a very important thing when working on the human body. And it also turns out that hospitals, do you know how many errors and quality defects there are in hospitals? It's a horrible, horrible thing. I work in hospitals a lot now, and it's shocking, shocking. So we want to build in quality at every step along the way. And this just shows very simple rationale for it. Maybe you've seen this before. So this shows, let's think about when I could find a defect or find a problem. Here I have in process, this is my process. Here's the next process, okay, that's you. And then there's final inspection, and then the customer. Think about that in terms of two things. My ability to find the cause of the problem and cost. Well, regarding cost, if I find it here, okay, I'm doing my job, and I see there's a problem. Oh, this doesn't fit together right. Okay, I've got a problem. The cost of fixing that is really, really cheap. Almost nothing. Although in the old Henry Ford days, that was a bad thing to do. No, don't slow down. Keep producing, keep producing. No, I'm going to tell you, stop. When you see any kind of problem, you stop right here, right now, and you fix it. It sounded like an expensive thing to do. You're stopping workers from producing. But actually, it's much cheaper because as soon as I send it to the next operation, the cost starts to rise. If I find that defect in final inspection, now it's very expensive. By the time it gets to the customer, now it's a very, very expensive thing, right? And now you've got a mess on your hands to deal with, right? On the other hand, when it comes to, let's see, ability to find the cause. Again, if I find it right here, me as the worker, oh, this doesn't fit together right because, I don't know, my impact wrench broke. Or, the materials doesn't seem to be right anymore. Somehow the screw's not working like it should. I can see what the problem is easy. I don't need sophisticated quality assurance tools, and a sophisticated problem, statistical process analysis. I don't need that. I can say, oh, it doesn't work. It doesn't fit together right. If it goes to the next process, it starts to get harder, right? Oh, this guy gave me something, it's not working right. What happened? You got to go back over here and find out, yeah? But by the time it gets to final inspection, it's even harder. Oh, it's the end of the day. We've already made 1,000 of these, and okay, what went wrong? Let's find out what went wrong this morning at 8 o'clock on that machine, right? It's harder to do. And then by the time it gets to the customer, my gosh, how many are out there in the field and you can't find them? Now you have to have all these very sophisticated quality problem-solving tools, right? If you do that. So this is first, build in quality. Next is one-piece flow, which we already heard about today. So a simple little illustration here. I put in some animation. For me, this is very fancy animation. This is very, very simple, and it's going to compare what happens if I produce in a batch versus I produce one at a time. Exactly what we were hearing about regarding the books, right? So let's say I have a product or an order for 10 products. Okay, make 10 of these. And I can either make all 10 at the same time and then send them on, or I can make one at a time, okay? Or make the parts for it one at a time, right? Let's compare what happens. Let's say it also goes through 3 processes, process A and B and C, to be completed. I make the bottom, make the top, I put them together. And let's see, and each one takes 1 minute. Each process takes 1 minute. So I have a little animation here. It's painful to watch intentionally, because this is the way you think it usually actually works. Okay, there's 1 minute, 1 minute, 1 minute, 1 minute, 1 minute, 1 minute. So I'm working, yeah. I'm sitting here working, banging these out. All right. Now I did my 10 bottoms. Now it's going to go over to the guy. It's going to be 10. Okay, going to do 10 of the tops. 10. Painful to watch because it's taking a long time. And that's right. So if you watch in factories, it's painful to watch sometimes. Yeah. It's kind of like real life. So the lead time, as you can see, is 30 minutes, right? 10 minutes here, 10 minutes here, 10 minutes here. At an absolute minimum. It's actually more than that. That's why it says plus to that, because there's going to be transportation time here, stuff is going to be going on. So it's actually much more than 30 minutes. But even a theoretical best is going to be 30 minutes for the full batch of 10, and at least 21 minutes to get the first part that I could sell. I could go in and take one off and sell one at this point in time. So if you care about money, you got money tied up here, right? Until the 21st one comes out. So now let's compare what happens if you do continuous flow. Well, 1 minute, I make one, I pass it on, okay? Now I get the first good one out after only 3 minutes instead of 21. That's pretty good. So I'm starting to get money back now. Right? Instead of having it tied up, I'm getting money back. But here's another thing that happens, kind of like magic. The lead time for the entire order went from 30 plus minutes to 12 minutes. That's an incredible thing, if I care about lead time. The fact is, in traditional production, we didn't care about lead time. I think back to some of the older folks in the room. Early in your career, did anybody talk about lead time? Not back in the day. We do now. But mainly you're thinking about how to optimize this piece of equipment, how to optimize this one, right? That's what we were worried about for all those years. So this, if you care about lead time, is a powerful thing. So this becomes one of the important principles as we think about designing a production system, which is short lead time. So what does that mean? First of all, here at the bottom, it says, so Taiichi Ohno, many of you know, was the guy at Toyota who developed the Toyota production system in the factories. Very interesting character. And what he said later in his career at the end, when people asked him to describe his system, he said, all we're trying to do is shorten the lead time. The time I get an order, that I can convert that into cash. That's all. Anything I'm doing to contribute to that, that's a good thing. And let's do that. All we're trying to do is shorten the timeline. So what does that mean from a standpoint of one-piece flow or what have you? It means get each process to produce what the next one needs when it needs it. So I'm doing this job and you're doing something over there. I'll make exactly what you need when it needs it, when you need it. So if that's the case, then from a production system design standpoint, we want to orchestrate everything to get closer and closer to that ideal. Because this looks nice. It's hard to do when you're thinking about some of the stuff we make in a car factory or any factory. It's not so easy always to do. So this is, so how can we orchestrate things to get closer to that ideal, ever shortening the lead time? So all the lean stuff we do in the factory, a lot of the lean stuff we do in the factories, it's about how we can shorten that lead time. So that leads us to thinking about the overall value stream. Yeah? This shows a look at a value stream from raw material, right? And I'm going to receive the resin to put this, to build this, and the screws here. It's going to go through a couple different processes. Let's say it goes through stamping, in this case molding, welding, and then assembly. Traditionally, the way I would try to improve my production is I would focus on each one of these, right? I'd have my really smart engineers out there working really hard. I've got welding. And to even take 1 second out of a 10-second, a welding operation is hard to do. But that's where I put all my energy. In the meantime, between these, tremendous amounts of waste is building up. So Ohno had the insight that if I can just focus my workforce, everybody, on taking out all the waste in between these, then that's going to contribute to a better system, shortening the lead time. Again, very obvious enough now, but it was a big innovation, insight back during the time. So there's the process step improvement that we do need to do. It's important. but also the overall value stream improvement. Again, that's what we were looking at regarding publications earlier, right? So that leads us to think about something that he emphasized a lot. I don't know, how many of you know the famous, in Lean, there's 7 or 8 wastes? You know, a lot of times in Lean 101, they talk about 7. Toyota always had 7. Now most people usually add 1 more, a waste of human talent or something like that. But the one that really matters from a production system design standpoint, those 7 are not created equal. If I can, elimination, he always taught, and what I learned was that's the worst one. That's an interesting thought, you know. I don't know if, so before I started learning this, would you have thought overproduction is the biggest enemy? You're out there in the factory, right? And you're trying to get stuff done every day, get through your 8 hours and produce things. Would you think that overproduction is your worst enemy? Not really, right? Any number of other things. He decided that this is the enemy. This is what's building up all the waste between these processes. So back to this one. Get each process to produce what the next one needs when it needs it. Just that. Just do that, right? And so think then of in terms of the overall value stream, not just each individual piece, and eliminate that overproduction. If you do that, you're going to create a nice, tight, shortened lead time production system that, as a result, it gives something pretty amazing happens. I don't know if, speaking of books, there are a lot of books now on like system thinking and system dynamics, complexity theory and stuff. It's a lot of fun if you read this stuff. It's also very complex. And yeah, sure, everything is a system. How do you change a system? I can only touch one part of it. Here's what this does, and this is an image that I learned when I joined Toyota almost 30 years ago. These are supposed to be rowboats. Do you have rowing in Hungary? I did a little rowing at one point. And what's interesting about rowing is, if you take a look at this guy right here, okay, the one that's circled in red, it doesn't matter how fast that guy goes, right? It's not going to help. It doesn't matter how fast he goes. In fact, not only is it not going to help, it's going to hurt, right? Well, if you think about production, I'm going to go back now a couple of slides. The same thing is true. It doesn't matter if this thing just starts going faster and faster and faster. If this isn't all synchronized, you're just going to build up a lot of stuff. And that's going to make things worse. Again, we never really thought of it that way traditionally. So it's a very interesting thing to think about. So I want things to be rowing at exactly the same rate. That'd be ideal. And if I get that, then I can have the shortest possible lead time. Okay? I don't know. Does this make any sense? Hope so. So that's kind of what the system was, really. And then in the tool age, as people started learning about Lean, TPS, they started rolling out the tools, all the different tools. You know, the tools are really, they can be powerful, wonderful things. But, you know, if you step back and look at the question that came up earlier about why sustainability numbers are so low, which is, I don't fully know the answer to that either, right? And that's a great question. We need to answer that question better. But my suspicion is a lot of it relates to this. So what Lean is, it has the techniques and the tools. And you can see those. Those are artifacts. You can see them. You can walk through the factory and see them. There's also a system, how they all fit together, right, to get the system efficiency like that, right? And also, and even more harder to see, there's a thinking that underlies the whole thing. And selecting the tools we like is not going to be enough. Oh, so this shows, I don't know, do you have a gambling in Hungary? Yeah, I saw a casino down there. So this is a roulette wheel, right? And it's got all the different tools there. Teams, it's the same list, probably, that we saw earlier. Similar list, right? You got SPC, statistical process control, teams, and on boards, TQM, setup reduction, SMED, you got all these things, quality circles. And you got the young engineer here spinning it, said, okay, next we'll try this one. We'll try this, you know, and we choose the ones we like. But you know, it's a system. So sometimes when you just choose this tool, it's not going to work unless you have it in conjunction with the other parts. The tools comprise a system. And just cherry picking, we'll say in English, cherry picking the tools is not enough. There's a way of thinking that underlies the tools in the system that we need to learn, I will suggest. And another important lean principle is you learn anything about lean, you learn through doing. So not really through, not through books. I hope that maybe the books can help. Maybe a lecture like this maybe has some value. But mainly it's you learn the thinking through doing. This is critical. So now let's get a little bit more specifically into what's introduced in that book, Learning to See. So when Womack and Jones came out with their book, 1996, I think it was, called Lean Thinking, they gave 5 kind of steps to follow. First was specify value from the standpoint of the customer. And again, we heard that earlier regarding the books, right? What does the customer really need? Mobility, the content of the book. What does the customer really need? And then identify the value stream for each product family, from concept to launch. If I'm in product development and engineering, concept to launch, or order to delivery. Specify the value stream and remove all the wasted steps. Make value flow, right? One piece at a time. Make value flow, shorten the lead time, start getting money back, start getting cash back. At the pull of the customer, again, regarding books, we discussed some ways that could start to work. When the customer needs it, not pushing it through. And then strive continually for perfection, always improving, always improving. This is the Kaizen mind, right? The Kaizen spirit. So these are the steps that Womack and Jones recommended. And a lot of folks have followed that. That led us then to making the book called Learning to See and introducing the tool value stream mapping. Now, what is value stream mapping? It is a tool to display the flow of material and information of any business process, manufacturing or otherwise, through all the steps, both the value-creating steps and the non-value-creating steps, as it moves from beginning to end. So it shows material and information flow. It's also then value stream mapping, and the way we introduce it in the book. So we borrowed the tool from Toyota. We slightly put a twist on the usage of it to use it as a process to align a team around a target condition. This is how we'd like our factory to work. We want our factory to look like this. And for a target condition or a future state for a given value stream and a plan for how to achieve it. So that's what we use value stream mapping for, to do this, okay? So this is the current state map. How many of you have seen one of these? How many of you have not seen one of these? Come on, you've seen one.
Yes, I saw yesterday.
You saw yesterday, okay. Okay, fair enough, fair enough, fair enough. Okay, let's see. Let me walk us through this very briefly, very briefly. What this shows is a customer here. It shows a factory, the processes of a factory here, stamping, spot welding 1, spot welding 2, assembly 1, assembly 2. I ship daily, 1 time a day, to my customer, and this is how much my customer needs. So this is like a car parts factory here, delivering to an assembly plant. And to make all that work, I have these forecasts, possibly coming from a computer, that goes through something, you could call production control, have maybe an MRP, that will develop a weekly schedule, and it'll blast the schedule out to everybody, telling everyone what to do when. The order descending from heaven, telling everyone what to do when. And it sounds good, but as we know, it doesn't work very well in reality, right? So in between each of these processes, you have a little, we have an inventory icon. We use a triangle with an eye at it. So that shows stuff being built up between these. I also have a little data box here that says how long each of the operation requires. This one's 45 seconds, 61 seconds, 39 seconds. And in between, I've got all this stuff. I've got a changeover time here of 10 minutes, 10 minutes. I see what my uptime is. This one shows 100%. If you ever see an uptime of 100%, basically say, no, I don't think so. And this one's 80%. And 80% too is too round of a number. Every so many operations, what's uptime? 80%. No, I don't think so. Anyway, so we learn about all these. So we put all that, just the necessary information there. Notice how at the bottom it's open-ended. It's one of these minor little things about the book that's intentional to indicate this isn't a checklist. This is for you to decide what's important about this operation. What do we need to know about this to know how it works, to know how it contributes to the overall system, the overall value stream. That's why it's like that. So people always ask me, what's the checklist? And I always say, think about it. Think about it. So now what you see is this thing, all this information coming down, and this tells us how it works. So then I can look at the value added, right, time, versus how much time is in the system. And we talked about that before. So now I have a way to look at that. In this case, okay, the time in the system here is 5 days. Then I have 1 second of value added stamping, yeah? Then I have 7.5 days worth of stuff. Then I have 38 seconds worth of a spot welding. Then I have 1.8 days of stuff. Then I have 45 seconds worth of spot welding. Now I have 2.6 days worth of stuff. Now I have 61 seconds of assembly time, and 2 days worth of stuff, and 39 seconds of assembly time, and then I have my finished goods inventory. So the time in the plant is 23.5 days, basically a month. And if you worked in traditional manufacturing, you know that's actually pretty common, right? From the time stuff comes in till it gets out, about a month or so is pretty average. And the value creating time here was, somewhat up front, can you? 184 seconds, 3 minutes. So to do 3 minutes worth of work, it's in the plant for a month. Now from this plant, it's going to go to another plant. The same thing's going to happen again. You know, and this is the way the world works. You know, with books or anything, everything that you buy, this is happening. This is just a disaster. Plus, people are driving themselves crazy trying to make it all work because you can't find the right thing. So that's the current state, the current reality. Okay. And let's see. So we did this book. So I was talked into doing the book. So maybe it could help. So one of the interesting things about the book is actually inside the first page there are a set of simple questions, possibly oversimplified, but our suggestion is that that's a starter set of questions for you to redesign your system. That the process laid out here is something that anyone can do. The first question is, what is your takt time? That means what's the customer demand rate? Okay? At what rate do we produce? 1 a minute, 1 30 seconds, 1 every 2 hours, what is it? Then you want to say, where can you flow? Just like Henry Ford, straight Henry Ford. Wherever you can flow, you flow there. If you can flow one at a time, flow. But you can't flow everywhere for a variety of reasons. Although we'd like to have the book, you know, not one of those big printing presses that makes a big batch. There's probably going to be some setup and some batch in a lot of different operations. Where some people have casting and machining. You know, that to have everything one piece flow may not be, in today's world, possible. So therefore, where you can't flow, pull. So then we're going to think about how to do that. How can you pull the production when you need it? Then, and this was a real twist. This was a new thing to introduce to the world with this book, which is at what single point in the production chain will you trigger production? Remember the traditional here? We got production instructions going everywhere. When that happens, you got a disaster. Okay, we're going to try to define it so that everything is going to trigger goes to one place. After that, it's going to flow where you're going to have pull. One of those two things. So then, 2 questions about where and how do you trigger that production? How much work do you take away? What are your batch sizes? And then how will you level that mix? Okay. Finally, at the bottom, we have a question about how to do the process improvement, the process Kaizen. And I'll jump ahead to a major point that I want to make here. It relates to that I believe it relates to that question about sustainability. Now, it's just my hypothesis. Many improvement initiatives begin here. Let's go improve something. Let's take SMED, let's take Kanban, let's take, and do that to try to make this better. It's very intentional that we put this question last. We're going to design how we want this factory to work first. Then we're going to use the tools we need to help us achieve that. So I'm going to suggest that that's a huge, deep difference. You might not even notice it. You visit a company and they're doing their process improvement and stuff. You know, after all, Plant A is doing quick changeover, so is Plant B. But Plant A may be doing it because that senior manager from overseas came in and said, I want everyone to do quick changeover. So we do it, right? Whether it was really helpful and what we needed here or not, This case, no. We're going to so this factory, that's plant A. Plant B is doing it because they had a problem there that they needed to get the batch sizes down. And so we're going to use this tool to design our production system. So in the book, and many of you know this already, there's a simple calculation to determine takt time, and that means we want to match the pace of production to the pace of sales as best we can, right? Again, they're not going to match up exactly. We'll get them close. And we have a simple calculation to do that. Then I'm going to decide where in my system should I have the pacemaker. It's going to set the pace. So if my takt time is roughly, what did we say here, 59 seconds, I'm going to find a pacemaker that I'm going to run that at 59 seconds. From that operation, everything down is going to flow, one-piece flow. And then everything up, it will pull. Okay? So that's the principle I'm going to use to design my production system. Okay? Okay? And why? What does that mean? Okay, the rules of production system are simply, the following process goes to the preceding to withdraw the amount needed. I think you referred to a fill-up system earlier today. And the preceding process is replenished exactly what is taken away. That's the most simple pull system. Okay, it can get more complicated than this, but this is the basic idea. So I've got a following process here. I need something. I send maybe a card through, or somehow I get what I need out of the store. Then there's another instruction that goes to preceding to make some more. A lot of people think a pull system is just, okay, we have a pull system because our following operation, they get what they want when they want it. That doesn't make a pull system. And that's what 90% of pull systems are that I see. No, it needs to be connected like this. Okay? And why do we do that? Basically because of this. And there's some underlying assumptions, which one is that production schedules will always change. Always, always, always. Number one. Number two, production will never go according to schedule anyway. That machine will break down. That customer will call up and cancel and change it. The employee will make a mistake. The employee will not show up. Something is always going to happen. Therefore, this idea of having this push system where you descend from heaven all the instructions is doomed to failure. So we're going to completely discard that and do something different. So we're also then going to level the production. And we're going to have very frequent movement of small quantities of stuff. So this is all explained in the book. I think I won't go into the details here. But we're going to break every batch, flow where you can, one piece at a time. Where you need some batch, make that batch as small as you can, and then rotate your frequency of different batches as frequently as you can. That will shrink your lead time. That will give you a more response. Shrinking lead time, that's an abstract notion in a way. It gives you better responsiveness for customers. You're going to be more responsive. So that's what we want to do. This is really fun stuff. I don't see many places doing this really well. Occasionally you do. And it's a wonderful thing when you see it. I'm sure you have some examples here in Hungary, and we should write those up and make them available on the website because it's a great thing to see. So those questions I just showed, going through those simple questions and putting it in place, it creates a future state out of that factory, that value stream, that looks like this. I'm going to say, what is my takt time? If I do the calculation, it comes out at 58 seconds. Okay? So that's the rate at which I want to flow. How do I know? And then I said what? Flow wherever you can, right? So where I can flow, the spot welding was what? 38 seconds. This one's 46 seconds. All of these are under 58 seconds, so I can flow through every one of them. Except it turns out this first assembly operation had 61 seconds. That's what that starburst is. That's what tells me what tool to use. That tells me in order to design this thing so that it flows from here to here, I've got to use some of my continuous improvement skills here to break that bottleneck. Okay? And it's assembly, so in this case they're able to do that by just rebalancing the workload to another worker. So now I'm flowing where I want. Then where you can't flow, you do what? You pull. This is stamping. It makes 1 second to make a part. I make a lot of different parts. It's shared equipment. I can't flow here, so there's where I put in a supermarket pull system. Okay? Flow where you can. So that tells me where I want to send my trigger. Where do I want to start the production flow? Right? So that tells me the one place to send the trigger. And everything else is going to cascade from there, to flow or to pull. Then I'd go through, so when I do that, all this difficult information Goes away. All this inventory between all these places, it goes away. Easy, easy. I don't have to control this now. Oh, should I have 2 days here or a day and a half? Am I getting too much or too little? It goes away. I've simplified the information flow. I've simplified the material flow just by answering those questions. And by the way, I haven't spent a dime. I haven't spent any here on any capital or anything. I haven't spent any money. Just changing the system by answering those questions. And at the end of it, the value added time is still the same, 184 seconds. So the difficult work of changing how the spot welding works, I don't have to do that. Just changing the system. Now it's in my factory less than 5 days. And anyone who's worked in a factory or managed a factory knows the difference between having stuff in my factory for a month versus less than a week. Your life is very different. You can go home Friday night and sleep better. And you don't get those calls late at night. It's a radically different world. So this, with those simple questions, but this defined how I wanted it to work, right? Which is this. Now I go in and I use my process Kaizen and tools for a specific purpose to solve a specific problem. So that's what's laid out in that little book. Now those tools can actually make sense. And I can learn them through putting them in place for a purpose. I think that's really a serious problem with the sustainability that we have. When you're just doing something because you were told, or because, I don't know, some abstract idea, it's not going to stick. But if you're doing it to solve a problem, to help yourself, to help your group, your team, your factory, then it's a totally different game, in my experience anyway. So let's see. I've got a couple more things before we opening up to questions and answers. This is my former boss. He's the chairman of Toyota today. I worked with him in Japan back in the early 80s when he ran production control in Japan. He was the first president of the Camry factory in Kentucky in the U.S. He was my boss. The last job I had with Toyota was to create something called the Toyota Supplier Support Center, working with different organizations to learn how to do TPS. And it was great. I had a chance to spend a lot of time with him and learn from him. And here's something he says that I thought relates to the book and that I would just share with you today. He says, whenever you try to do TPS, he was one of the original group, by the way, that developed TPS back a long time ago, one of the few who's still alive, said, when you try to apply TPS, the first thing you'd have to do is try to even out or level the production flow. And that's the responsibility primarily of what he calls production control. I introduced this because essentially that's what we're talking about in this book, Learning to See, and all that I just took you through. So that's an interesting thing. Let me tell you, I don't know many companies that have something that I would call production control the way it exists in a good lean enterprise. Production control is the interface between the customer requirements and the company capability, which never match up completely, right? Of course they don't. But we want to get them to match. So this production control then has to satisfy both sales, what sales wants, and manufacturing equally. So they realized that this was an important thing, and therefore they, Toyota, Mr. Cho, and so they created this group they call production control. And they put together the best and brightest in the company, like, okay, half engineers and half business people in the same group, and said, we want you to innovate. So that, given that challenge, that group had to be really strong to be able to do both. And that's why all these innovations that I was just sharing about pull systems and Kanban and all that, that's why they were able to do that. They created this group and said, we want you to do this. To give you just a little more idea about how important that was, in Toyota at that time, there were about 200 or so different departments, right, when I worked there. Each one had a budget. I don't know, do you guys have a budget where you work? Right? Everyone had a budget, except one department did not have a budget. That was this department. And it's not because they forgot to give them a budget and gave everyone else a budget. They didn't want a smart young engineer or accountant sub-optimizing the whole. They wanted these people to figure out how to make everything flow beginning to end with short lead time. They realized that was a very important thing to do, and not then to have someone just thinking about, you know, make sure all the trucks are filled to the top and and try to optimize the trucking. They wanted to optimize the flow to the customer. So what that means is, I'm going to introduce a couple of more important things. A couple of Japanese terms here. Sorry. Many of us know the term muda, which means waste. Not as many of us know two other terms that are supposed to go along with it. So again, it may relate a little bit to some early misunderstandings as a reason of the lack of sustainability. This tries to show that the challenge of any business we're going to say, is matching capacity or capability with demand. That's all I need to do. Demand is here, my capability is here, try to get them to match up. Now they will never match up completely, but trying to get them to, if I can get them to match, I'm going to be successful. So this black line shows demand is changing. Demand will always change. Customers are always crazy. And in response to that, I'm going to put in a certain amount of capacity, capability. That's what the red line is. Now, when those match, I'm going to be very successful. When they don't, I've got a problem. If I've got, in this case, it shows I've got this much capability for this much demand, yeah? Then demand goes up. At this point, I'm either doing one of two things. Either I'm losing sales, or I'm pushing my system to do more than it's capable of. I'm overburdening people and equipment, which will break. It will break eventually. Okay? We can only do work 90 hours a week for so long before we break. The equipment can only be sped up so many times before it's going to break. Yeah? So then, in response to that, I put in some more capability, capacity, right? So now, demand goes down. Again, it's always going to happen. So this all then is muda, is excess. And it goes like this. So I want to try to get them to match. So this means knowing my demand, which is hard to know, really understand my customer. Then know your true capability, your true capacity, which is also not so easy to know. Seems like it would be, but I have not seen a factory yet that didn't have all kinds of hidden capacity out there, right? You can't get out. And then create flexibility to get them to match. So these are those words again. So this is overburden. And you know what? The person who's trying to do this can't do anything about it, right? This is what the workload that's given to us, right? I'm a piece of equipment, and I'm being sped up, okay? And I'm a worker trying to do the job, and all of a sudden the right material's not there. I have to switch over to do another one, right? I can't. So the first thing we need to do is design the system with sufficient capacity to fulfill customer requirements without overburdening people, equipment, or methods. Secondly, we need to reduce the variation, the fluctuation, to a bare minimum. Once I've done that, now I can comfortably eliminate waste so that it doesn't come back. Until I work on these two, the waste is always going to come back. The waste is going to be, it's being caused by those two things. So those of us who are leaders, our job isn't just to get out there and try to help the workers, the front lines, eliminate waste. Usually as leaders, when we go out there, we cause more waste. Okay? We can help, we can support, okay? And we need to, but our real role is to do this, okay? So I'm suggesting that with that tool that we're introducing to you, it's a system design tool. It looks very simple, it is very simple, but it gives us a means by which we can actually design our work systems as a material and information flow system, okay? With inputs and outputs. That's what we want. So value stream mapping then, used fully and properly, does much more than simply identify waste to eliminate, which unfortunately many people have used it for. It's a tool and a process to design lean, value-creating systems that the people who work in the system can be a part of designing together. So then we can continuously improve to make things better for ourselves. So I think that was back to that simple definition. So that means then finding ways to develop people, process, and systems to meet the customer needs, consuming the fewest possible resources. In that presentation, I talked about the process and systems development, not the people part. We'll talk about that this afternoon with the A3. So there's a lot of stuff in 1 hour. Thank you. Thank you.
Okay, thanks a lot for this really exciting presentation, and now we are at the question and answer times, és nem tudom, hogy most ezt hogy csináljuk, igazából önöktől kérem, I don't know, what do you prefer, do we have to ask you in English or in Hungarian and it will be translated for you, tehát hogy csináljuk, hogy magyarul kérdezik, és akkor ezt...
If you ask in Hungarian, yes, you will have to translate it.
Yes. It is the best way, yeah. Jó, tehát azt szeretném mondani, hogy ha bárki tolmácskészüléket használ és szeretne kérdést föltenni, akkor ne habozzon, hanem tegye fel nyugodtan magyarul. Jó, akkor John felrakta a fejére a fülhallgató készüléket, tehát fogja érteni, és aki meg angolul szeretné kérdezni, az meg, de akkor is lehet magyarul kérdezni, hogyha, tehát nem muszáj, hogy tolmácskészüléknek lenni, hogy magyarul kérdezzék, csak kérdezzék. Ja?
Németh Balázs vagyok, és a kérdésem az lenne, hogy a pacemaker állomás minden esetben a bottleneck machine. My question would be, the pacemaker process is always the bottleneck machine, and when is it the bottleneck machine and when is it some other machine?
Okay.
Or a step in the process.
Okay. Everyone understand the question? So, this is an interesting question. And actually, maybe I can even, oh no, I can't. It's okay. So, how many of you are familiar with the theory of constraints, TOC? And with theory of constraints, you identify your bottleneck and you will throw resources at that so that doesn't become a constraint. And as you break that one, you will then move to another one. Okay, the pacemaker, as I was describing it there, so the answer is no, they're not the same thing at all. And so this is a fundamental and important difference between the lean flow and TOC. There are a lot of commonalities between TOC and lean flow. However, I'm going to design my system so that it works the way I want it to work. Why would I choose my problem operation that's then going to drive me? I'm going to determine how I want it to work. I'm going to choose the pacemaker based on that. That may or may not be a bottleneck. I'm going to start with my customer demand rate. And then where my process capability is, that will determine where the pacemaker is. Not the fact that I have a broken process. That's a crazy idea to me, that I would want to let some bad thing determine what my pacemaker is. So that, however, once I've done that, I've chosen the pacemaker. When I have bottlenecks, I have to use the same tools that TOC uses to go break that bottleneck. It is a problem. But no, I'm going to set my pacemaker based on how I want my system to operate, based on the fact that I'm going to flow from there on and pull upstream. So it's a very fundamental difference, actually. And something probably almost no one realizes. Anyone else? Remember, it's just me and you sitting here. There's not 99 more people. It's just two of us.
So John, sorry, I wasn't on. Probably not. Still not. Okay. So John, as we discussed previously, I'm pretty much interested in some of those stories of history, like when you learned these things, and I would be interested in if you can give me an example that you said that you took the practice from Toyota as you learned, and you a little bit modified it so it became a process. So how was it in the days when you learned it in Japan? What was the exercise, or what would be, how you used value stream mapping, if there was anything such, the same way as it is today?
Okay, I'll try very briefly. Maybe I can add some more things this afternoon when we talk more about learning and things like that. But yes, this tool existed in Toyota already, not from a long time ago. Really probably in the 80s, when I was there, it was developed, maybe late 70s. And Toyota calls it material and information flow mapping, which I actually preferred to call it that as well for a long time. So sometimes we think of a production system as having three flows: the material, the information, and then people, how people work within this. And M&I flow only shows two of those. So it shows that as a system on a two-dimensional map. Yeah. The way that I learned it at Toyota was as a tool for specialists. So there was kind of a TPS, Toyota Production System, kind of advanced expert group that would use that tool to analyze factories, to analyze operations, and to discuss amongst that small team different things they were doing at different suppliers and different factories. That's how the tool was used there. So my first experience with it was at I don't know, so the Japanese word Kaizen, right, and doing improvements. I was at my first real Kaizen event, some of you do like Kaizen workshops or continuous improvement, rapid improvement events, they call them a lot of times, where so traditionally the way those work is it's often 4 or 5 days. And in day 1, you go in and you often will map out the work, or at least do the standardized work drawings, perhaps map it out. And you'll analyze the operation. And you'll sit there with a stopwatch, and see exactly what's happening, observing firsthand. What we like to do in lean stuff, by the way, if you've gotten into this, there's nothing we love more than observing work. We just love to observe work. So printing presses, or go to the airport. So it's a very dangerous thing, right? I mean, it starts to drive you crazy. You go to the coffee shop, and all of a sudden the line is getting long. You want to get behind there and help, right? And that's the fun part of lean. It's really it's a lot of fun. You start thinking about books and how it could be done better. That was a great discussion earlier. It's a lot of fun to think about how these things could be better at the micro level, but also at the big system level as well. So we'll take these stopwatches, we'll observe, right? And day 2, you'll observe some more, and then you'll put in the changes. And then day 3, you'll fix what you screwed up on day 2. Because you always got something wrong. You always make things worse for the operator. So the idea is you need to make things better for the operator. You always make it worse. I mean, we'll do it every time. Why is the sustainability a problem? It's often that. And then at the end of the 4 or 5 days, you'll kind of do a report out. And they tend to be, so it's a lot of fun. If you've done those, it's tremendously energizing. You learn a lot. You can make some improvement. But the way those have been used, by the way, in a lot of cases, is as the primary mechanism to bring in lean transformation. That was not really their first intention. It was really a way for people to learn, so then they could bring it to play in their daily work. So for me, getting trained by that advanced group, I got to work with them. I learned this tool, material and information flow mapping, as a way to map out what a Kaizen event might be. So we had this big vision of how the plant would work, so then we do little events to try to break down bottlenecks, okay, or establish the pacemaker, right, or whatever. In fact, the first time I saw that, because I was just doing the detailed part, right, looking at standardized work. I wasn't part of actually using that M&I flow map tool. That was my sensei was doing that. And the first time I did it actually was a 3-day event, 3 days. So the first day, you spend all day standing on the floor. You got a stopwatch, you got a little chart, you're drawing up what's happening. You stay there all day. And then you go grab a bite to eat. And then, okay, well, we have to go confirm what happens on the second shift. So you go to the second shift, and you stay there again, all second shift, all night. You don't even go home, you stay all night. It's amazing. The next day comes along, and now you got to start putting in place some of the changes you come up with. So you stay there again all day. And then that night, I'm thinking, oh, maybe we can sleep tonight. And no, you stay there all night again, making sure that the changes work on the second shift. And that second night, I cheated. I slept 2 or 3 hours. But the other, my colleagues did not at all. Again, it was me. The rest of them were the Japanese there. And I slept a couple of hours. I was the weak American. Out of 3 days, I slept a couple of hours. So that's the first I saw the tool, but I wasn't really using it. My sensei was. I was doing the other stuff. And just one more thing about that particular story. Because I talked about the material and information flow so far. And it is the people part that's the most important part. And as I was trying to think of ideas to improve that case, it was like a machining and welding cell that was a feeder line for in one of the assembly plants. So it was an assembly plant, but not on the main line. It was an off line. And I kept thinking about these things that could get more production output, and making these improvements. I was eliminating this waste or that waste, and, trying to push production up. And finally, after a long time of my sensei not being happy with my suggestions, finally he said, so why do you keep trying to push more things out? Why don't you just make things easier for the operator? See the way he has to walk all the way over there to get parts every time? See the way when he needs to get his impact wrench, he has to reach up way over here? See the way when he has to pick up, there was a certain fairly heavy part he had to pick up and move it over here? Why don't you just take stuff away, make it easier for the operator, And then that's going to get the improvements you wanted anyway. And I said, so why didn't you just tell me that in the beginning? And he said, well, I couldn't remove the blockage in your mind until the blockage was there by having the bad ideas. So anyway, that was an early experience, not directly with the tool, but with that tool was used to design the overall Kaizen event that we were doing. So that's probably...
Thanks, yeah. Okay. De még lehet, hogyha, I don't know, maybe somebody else would like to ask you. Van még esetleg kérdés? Igen, ott hátul látom az urat, ott a mikrofont, ott a tolmács fölk előtti asztalnál. Köszönjük.
Hello, this is Zoltán Gábor from G Healthcare. I would like to ask, when do you think we will see on these kind of conferences, instead of production examples, more like services or those kind of examples and the tool set according to those needs? Like a value stream map instead of showing a factory, showing a, I don't know.
Sure. Well, we have, I think you know, we have lots of examples of value stream maps in healthcare and service examples. And I think, I imagine with these conferences we'll add more of those different activities as well. I spent most of my last 10 years working in places like healthcare, in hospitals, also working in coffee shops. I love coffee. And I've worked a lot in coffee shops and as well. You know, it's amazing. Yeah, I realize the need to do that. In fact, I'm very interested in service and how we can bring this more, because service levels, most places in the world is just terrible. It's just terrible. So out of frustration, I would like to see more of this brought into the service world. Healthcare has been amazing to watch. I had the first time I did some work in healthcare. It was at a clinic, an outpatient clinic, on the west coast of the U.S. It was shortly after this book came out. And so I was dispatched to go to do this in a clinic. I had no idea what to do, if it would work. I had no idea whatsoever. And I didn't know what else to do. So I took the healthcare team, the doctors, the nurses, the staff, exactly through that example that I just showed you. And I said, I don't know if this will work in healthcare or not. But so it was about 30 people. We went through that. And to my great surprise, even those exact questions, it worked beautifully. Now, making the changes in healthcare has all kinds of social dimensions, organizational issues. Doctors hate nurses, and nurses hate doctors, and the staff hates them both. And so getting people aligned, it creates all kinds of problems. But it starts with quality again. I mean, in the United States, anyway, we talked about errors there, and I don't know. In the United States, every day, there are 2 or 3 it's called wrong side surgery. Can you imagine anything worse than a wrong side surgery? You go in and you're going to have your left leg operated on, and you wake up and somehow there's a bandage on your right leg. And that happens every day, 2 or 3 times in the U.S. Every day. So what they do to make that not happen, you know what they do? They'll like to do little things like put a big black X on the leg you're supposed to operate on. And then before the operation, they'll ask you, what's your name? Which leg do you want to be operated on? And so this building in quality is an incredibly important thing. In the U.S., every year, there are 300,000 medication errors. I can go on forever. So once in a hospital, I was part of a team in Australia, actually. We videotaped the work of a nurse. Took a 40-minute videotape. And then sat down with the nurse later and went through and looked at her work and talked about it. At the 37th minute, she administered some medication to a patient. Beautiful job, talked to the patient very, very, very kindly. And then, but we didn't know until we talked to her that she had been trying to administer that medication for 37 minutes and couldn't because she kept getting interrupted. Because there was no standard work. There was no recognition and respect for the work that she was doing. And what do we know about the way, built in, I didn't talk about it today, but built into how we build quality in the assembly plant. I'm going to go back to the assembly plant. One of the reasons the way we construct the system is so we don't interrupt people in their work, even a factory worker. Because when we make errors, any engineers here? You're sitting there working on an engineering problem. You ever have someone come up and interrupt you? That's a joke, right? People interrupt you all the time, tap you on the shoulder. Then you help them for 2 hours. Then you turn your attention back to what you're working on and you forget, right? Oh, where was I? What was I thinking about? Well, that's what's happening to nurses and doctors all the time as well. They're getting interrupted. It's what's going to happen on an assembly line worker. It's what's going to happen to a doctor. So I think, more examples that can speak to different people with a different language is useful. My own experience also has been, it's amazing to which it's the same. At the end of the day, it's amazing. And I would not have thought so, again, in the beginning, whether healthcare or another job I had once. I was a senior for Toyota. I was the senior American for their technical center in the United States in about 1990. Because we were Toyota, we had been building cars in the U.S. for a few years. And so the first thing you do when you go to a country is like we were talking about earlier about the multinationals. Typically, there's a three-step process. First, you go to sell, right? You sell your product. And that's easy. You hire the best local salesman you can get. So you just sell, use your local connections and local knowledge of local culture and sell as many as you can. And once you build up enough market share, volume, you want to produce there because it makes sense to produce close to where you sell, right? And the third thing then is design, development, and engineering. Because once we have our manufacturing and engineering separated, I think many of you know, then all kinds of problems can occur there as well. So in about 1990, after I'd been working with Toyota on production for several years, I was the senior American at this technical center in Michigan, in the U.S. And I walked in then. I'd learned the TPS stuff. I'd learned all the Kanban calculations. I'd learned all the, all those things that we were talking about there and more. And I had a pretty simplistic notion of how to apply those. So I remember the first time I walked into the CAD CAM room, where now we have American engineers, okay, who are using their minds, not their bodies. And these are people we hired from Ford or from GM or out of college. And they're sitting there doing their work, right? They have their monitor and doing CAD work. And there was a guy there who I'll never forget. Let's see, he had his arms crossed like this guy here, right? Sitting with his arms crossed. And I watched him, and a minute went by, still sitting there with his arms crossed. 5 minutes went by, 10 minutes goes by, he's still sitting there with his arms crossed, looking at the monitor. And and I said, well, gee, is that waste? And the answer is you don't know. The answer is you don't know. He may have been solving a very difficult calculation, difficult problem, or he may have been thinking about his date Friday night with his girlfriend. And but I couldn't know from that. But what I did eventually realize is the waste is there. The long lead times are there. The work is not flowing, it's building up in batches. People are just producing without building in quality. So all those things and those questions actually still apply amazingly. The parallel is amazingly close in any work that I've seen, including service work. It becomes more difficult because you can't see the work. A lot of the work is invisible. Okay. And there is usually more variation, more variation. And so I agree with your statement that we need to have better and good ways of dealing with that. There are books that introduce value stream mapping in those in non-production environments. And we have those examples, and I think we probably should introduce more of those the next time we do this. I think it's a good point. In fact, GE Healthcare, you can help. I think, right? Okay, good, thank you.